I bet you didn't know why your coffee cools down or why the sky turns red at sunset. The science behind these everyday phenomena might surprise you. Join us at BuzzTrek, where we explore the fascinating world of science that surrounds us. From the moment you wake up to the time you drift off to sleep, science is at play, quietly orchestrating the wonders of our daily routines. So buckle up as we embark on this exciting journey of discovery. Get ready to unlock the mysteries behind the seemingly ordinary, because science is everywhere, and it's anything but boring. Alright, science sleuths, let's unravel the mystery of why that steaming cup of coffee always seems to cool down on us. You see, it's all about a little something called thermodynamics, the study of how heat moves and grooves. Now, heat is a real social butterfly. It loves to spread the love, always moving from warmer objects to cooler ones. So, your piping hot coffee brimming with energy just can't resist sharing that warmth with the cooler air around it. This transfer of heat happens in a few ways: conduction, convection, and radiation. Conduction is like a chain reaction where hot molecules bump into their cooler neighbors, transferring energy along the way. Think about holding a metal spoon in hot soup. The handle gets hot too. Then there's convection, where heat travels through fluids like air and liquids. As the air near your coffee warms up, it becomes less dense and rises, making way for cooler air to swoop in and steal more heat. It's like a never-ending conga line of air molecules. And lastly, we have radiation, where heat travels as invisible waves, like the warmth you feel from the sun. Your coffee radiates some of its heat out into the world, slowly but surely. So there you have it, the case of the cooling coffee cracked wide open by the power of thermodynamics. Have you ever gazed up at the sky and wondered, why is it so blue? Well, get ready for a dose of atmospheric optics. It's all thanks to a phenomenon called Rayleigh scattering, named after a brilliant physicist, Lord Rayleigh. You see, sunlight isn't just one color, it's a mixture of all the colors of the rainbow, like a beautiful invisible rainbow whizzing through space. When sunlight enters the Earth's atmosphere, it encounters a whole bunch of tiny air molecules: nitrogen, oxygen, you name it. And you know what? These molecules are like picky eaters, but instead of food, they prefer to scatter certain colors of light more than others. Blue and violet light, with their shorter wavelengths, are like the life of the party. They get scattered everywhere. Our eyes are more sensitive to blue light, so we see a brilliant blue sky most of the time. But what about sunsets? Well, as the sun dips low in the sky, sunlight has to travel through more of the atmosphere to reach our eyes. This means the shorter blue and violet wavelengths get scattered so much that they're almost all gone by the time the light reaches us. The longer wavelengths, like orange and red, are like the last ones standing, painting the sky with those warm, mesmerizing hues. So, the next time you catch a breathtaking sunset, remember Rayleigh scattering, the maestro behind nature's spectacular light show. We've all been there, that irresistible urge to yawn, especially when we're tired or bored. But why do we yawn? Well, scientists are still debating the exact reasons, but one leading theory suggests it's our body's way of giving our brains a much-needed boost. You see, our brains are like high-performance engines, and they generate a lot of heat when they're working hard. When we get tired, our brains tend to warm up a bit, and that's where yawning swoops in to save the day. Think of yawning as a built-in air conditioner for our brains. When we yawn, that deep inhale brings in a rush of cooler air, which helps to regulate our brain temperature. It's like giving our brains a refreshing blast of cool air to keep them running smoothly. Plus, yawning also stretches our jaw muscles and increases blood flow to the head, which might further enhance brain activity. So the next time you feel a yawn coming on, don't fight it. Embrace it as your body's way of keeping your brain cool, calm, and collected. Chapter 4, Up, Up, and Away, The Science of Flight. Have you ever looked up at an airplane and wondered, how does that massive hunk of metal stay up there? It's not magic, it's the science of aerodynamics. Aerodynamics is about how air and objects interact. 4 key forces make flight possible: lift, thrust, drag, and weight. Lift counteracts gravity and keeps the plane aloft. It's generated by the wing's shape with a curved upper surface. As the plane moves, air flows over and under the wings. Faster moving air above creates lower pressure. Higher pressure below generates lift, pushing the plane up. Thrust propels the plane forward, generated by engines. Drag is the air resistance the plane encounters. Streamlined designs reduce drag. Weight is gravity pulling the plane down. These 4 forces work together to make air travel possible. Chapter 5. Rainbow Magic, Unlocking the Spectrum. Rainbows, those mesmerizing arcs of color that grace the sky after a storm, have captivated humans for centuries. But have you ever wondered how these dazzling displays of color come to be? Well, get ready to explore the science of rainbows, where light, water, and a little bit of magic combine. Rainbows are all about the interaction of sunlight and water droplets in the atmosphere. It's like a giant sky-sized prism effect. Sunlight, as we learned earlier, is a mixture of all the colors of the rainbow. When sunlight enters a water droplet, something fascinating happens. It gets bent or refracted. You see, light travels at different speeds through different mediums. When it passes from air to water, it slows down, causing it to bend at an angle. But wait, there's more. As the light travels through the water droplet, it hits the back surface of the droplet and bounces back, or reflects, like a tiny mirror. And as the light exits the water droplet back into the air, it gets refracted again. Now here's where the magic really happens. During this journey of refraction and reflection, the different colors of light get separated. Remember how sunlight is a mixture of all the colors? Well, each color has a slightly different wavelength, and they bend at slightly different angles. Red light with its longer wavelength bends the least, while violet light with its shorter wavelength bends the most. This separation of colors is called dispersion, and it's what creates the spectrum of colors in a rainbow. Chapter 6. The Curious Case of the Floating Ice Cube. We've all been there, tossing ice cubes into a glass of water. But have you ever paused to ponder why those chilly cubes decide to float instead of sinking to the bottom? It might seem counterintuitive, but it's all thanks to a fascinating quirk of water: its density. Density is a measure of how tightly packed together the molecules are in a substance. The more tightly packed they are, the denser the substance. Now, here's where water gets a little weird. It's actually less dense in its solid state, as ice, than it is in its liquid state. How is that possible? Well, it's all about how water molecules arrange themselves when they freeze. In liquid water, the molecules are like a bunch of friends at a party, mingling, moving around, and constantly bumping into each other. But when water freezes into ice, something fascinating happens. The molecules slow down and arrange themselves into a rigid crystalline structure. And guess what? This crystalline structure has more open space between the molecules compared to liquid water. It's like the water molecules decided to spread out and practice social distancing. This open structure makes ice less dense than liquid water, and that's why it floats. Chapter 7. Magnets, Attraction and Magnetism Unveiled. Magnets, those mysterious objects that can attract certain metals like iron, have fascinated humans for centuries. But what's the secret behind their invisible pulling power? Well, get ready to delve into the world of magnetism, where invisible forces reign supreme. It all starts with electrons, those tiny negatively charged particles that whiz around an atom's nucleus. Electrons are like tiny spinning magnets themselves, creating their own miniature magnetic fields. In most materials, the magnetic fields of individual electrons cancel each other out, resulting in no overall magnetism. But in certain materials like iron, cobalt, and nickel, the atoms have unpaired electrons whose magnetic fields align with each other, creating a net magnetic field. It's like these atoms decided to join forces and create a magnetic superpower. This region around a magnet where its magnetic force can be felt is called a magnetic field. It's like an invisible force field that extends outward from the magnet. Magnetic field lines, often visualized as lines flowing from the magnet's north pole to its south pole, show the direction of the magnetic force at any given point. Opposite poles attract, while like poles repel. It's like a magnetic dance of attraction and repulsion. So the next time you see a magnet working its magic, remember the invisible world of electrons spinning and aligning their magnetic fields to create those fascinating forces of attraction and repulsion. Outrow, keep exploring the science around you. From the cooling coffee in your mug to the breathtaking hues of a sunset, the world around us is brimming with fascinating scientific phenomena waiting to be explored. Remember, science isn't just confined to textbooks and laboratories. It's happening all around us, shaping our everyday experiences in remarkable ways. So, keep those curious minds engaged and never stop questioning the world around you. What everyday wonders have sparked your curiosity? Share your thoughts in the comments below, and don't forget to subscribe for more exciting science adventures. Until next time, stay curious.